Hello grade 10! Our topic for today is Charles' Law. In our previous lesson, we already studied the relationship of volume and pressure at constant temperature. And today, we're going to explain the relationship of volume and temperature at constant pressure. If you remember in our last topic, kinetic molecular theory, it is stated that the kinetic energy of a gas molecule varies directly with the temperature. As the temperature increases, the molecules move faster. In this image, the effect of the changing temperature on the volume of a gas, the pressure or the amount of the gas must remain the same or constant. It shows that when the temperature increases, the kinetic energy of the gas will also increase. And to keep the pressure constant, the volume of the container must increase. This behavior of gas was explained in Charles' Law. It was named after the French physicist Jacques Charles, who discovered the direct relationship between the volume and temperature at constant pressure. Charles' Law states that the Kelvin temperature and the volume of the gas are directly related when there is no change in pressure. Charles' Law expressed mathematically as V1 over T1 is equals to V2 over T2, where V1 is the initial volume, V2 is the final volume, T1 is the initial temperature in Kelvin, T2 is the final temperature in Kelvin. In solving a problem about Charles' Law, we also use the unit of conversions of Celsius to Kelvin. To change Celsius to Kelvin, just add 273.15. In this table, you must also be familiar in unit used in measuring volume. So let's have a sample problem. A neon gas at 760 mm mercury has a volume of 12.0 liter and a temperature of 44 degrees Celsius. Find the new volume of the gas after the temperature has been increased to 85 degrees Celsius at 760 torr. Since the temperature are given in degrees Celsius, you must first change them into Kelvin. So we had the initial temperature of 44 degrees Celsius plus 273 is equals to 317 Kelvin. And we have the final temperature, which is 85 degrees Celsius plus 273 is equals to 358 Kelvin. So placing all the information in this table, you will see we're looking for the final volume. To solve for the final volume, we're going to derive the formula. The derived formula that we're going to use is V2 is equals to V1 times T2 over T1. So we're going to substitute all the given value. V2 is equals to 12.0 liter times 358 Kelvin divided by 317 Kelvin is equals to 13.55 liters or 13.6 liters. A direct applications of Charles' Law can be seen in such equipment like an incubator. When air comes into contact with the heating element, it expands and becomes lighter. This lighter air rises, causing the circulation of the warm air throughout the incubator. Also, one good example of Charles' Law application is the hot air balloon. If a balloon is filled with a heat gas, its volume must expand. And at elevated volume, the balloon then occupies a large volume in the same weight as the surrounding air. Its density is now less than the cold air and consequently, the balloon begins to rise. And that's all for today. Till next time!